We're at go2math.com. Click on the calculus button. Let's go down to the disk method. Click on that. What are we doing? Find the volume. Let's do this one here. 2.2. I think I've done that. Find the volume of the solid formed by revolving about the. What are we revolving? Evolving. We're revolving this guy, the shaded region, if you can imagine. We're going to revolve that about the x-axis. And what are we getting there? Some strange thing. Alright, let's write this down. We're getting something strange, it looks like. F of x is equal to x and g of x. So in the real world, if we were trying to find the volume, which is actually really important, especially if we need to know how much material we need to order, right? We'd probably have to drive up our own equations to match whatever this is, you know, the inside and the outside surfaces. Um, but since we've got all this 3D printing technology these days, this could actually, a lot of people could be doing this now. I mean, actually utilizing this stuff. Let me go ahead and write these functions down. Well, I'd like to have a 3D printer. I could think of all kinds of things I could print up, but they're a little out of my price range. A decent one is anyway. I've got all kinds of cool mathematical stuff I'd like to print up. Especially, I've designed this has been about 10 years ago. It's not a kaleidoscope, it's a dodecahedron scope. And you drop something down into the scope and it gets reflected around and it looks like it's in 3 dimensions. Whereas a kaleidoscope, everything is in 1 dimension. I'd like to have a 3D printer to actually make a few of those. So if anybody out there with a 3D printer could help me out. Alright. What are we doing? I don't know what we're doing. We're going to sketch this thing out real quick here so we know what this looks like. So that's pretty easy line to sketch. We're going from 0 to 3. We'll just put 3 right here. And of course my graphs are never to scale. Who's got time for all that? Alright, so here's some shaded region here. Alright, so technically, you know, we're using the washer method. I should mention that. But what you need to really understand is, you know, that we're doing the disk method and we're taking the larger radius, which is going to be here, and subtracting off the inside volume. Okay, we're taking the whole volume and then subtracting off the smaller volume and to actually get the volume that we want to get. Right? I hope that makes sense. Man, this is going to be tough to draw. I'm going to attempt to draw something here. Like I said, it's just an attempt. But what it looks like is, well, actually that could be solid. Solid going around like this. And then we got this inside stuff. That's not meeting towards the middle, is it? No. It's going like to right here, I guess. Oh no, this is more flat down here. Yeah, that's not coming to a point. That's flat, actually. Okay, well, anyway, it's something like this. We're finding the volume of this piece here. Right, subtracting off the inside. Subtracting off the inside. This actually comes to a point. Comes to a point like that. Right? Anyway, it's something like that. Oh, you know what? It's actually going all the way down here, isn't it? To a point. Yeah, that's what it's doing. Okay, so how do we do this? Well, we do it just like we've done all the rest of them. We are going from 0 to 3. Now I'm going to find the larger piece from 0. Sorry I spent so much time on that. 0 to 3. Okay, find the volume of the large one. 0 to 3, and that's going to be this guy right here. So this is the larger radius. X plus 5 quantity squared dx. Don't forget there's a pi out here. Piece of pi. Minus, and then we subtract off, if we were just revolving this piece around it, the x-axis, we subtract that off. So pi going from 0 to 3 of, that's just x squared dx. Now remember, while we're squaring this, because the actual formula, right, is pi radius squared times dx. And remember, that all comes from this formula here, pi r squared times h. And that, remember, this is the formula for a cylinder, but our radius is changing, okay? And we don't know what the length of the cylinder actually is, or the height of it. Okay, so there's our two setups. Now, this guy here, you can either square this thing out, or we could use u substitution. Let's use u substitution so we don't get rusty on that. We let u be x plus 5 du is equal to derivative of x is 1, that's 0, so we're left with dx, right? Okay, so this becomes u squared du, and then we take the integral of this. Now you can go ahead and change these limits if you want by plugging 0 in here, okay, and then plugging 3 in to get your lower and your upper limit, but we're just going to leave it right like that, okay? And so that ends up with u cubed over 3. But then let's get everything back in terms of x. Don't forget this pi over here. And so we end up with, I'm going to go ahead and plug x plus 5 back in. Now you may have not have seen me do it like this, but that's what we're doing. And we're going from 3, okay? Alright, we're going to use the same limits now, okay? Now, and we're going from 0 to 3. Alright, so that's that guy. Now this one here, let's go ahead and write minus pi x cubed over 3, going from 0 to 3. There, going from 0 to 3. So minus pi x cubed going from 0. We'll just rewrite that right there. I don't know what I just did that for. And okay, we can actually, what happened? Oh, I hit something there. We could actually just combine these instead of doing these separately. Okay, you know what, I'm going to do this. Minus x cubed going from 0 to 3. See what I did there? I pulled the pi and the 3 out of both of these since they were in both, right? And since our limits are the same, 0 to 3, 0 to 3, we can do that, okay? So we're just going to plug 3 in now, so we have pi thirds. 3 plus 5 is 8 cubed minus 3 cubed, which I actually know that. Supposed to be an equal sign there. And then minus, and we plug 0 in. Yeah, we better do that. You know what? I'm going to factor out this pi thirds here. So now we want to go ahead and plug 0 in. And I remember when I was doing the programming, I just assumed that was 0 and that was 0 and didn't. Yeah. You got to go through all the steps. Don't try to skip anything. Minus 0 cubed. Alright. And what do we got here? That's, let's see, 8 cubed. I don't know that off the top of my head, and I don't. I do know 3 cubed. You know, let's not waste any brain power. 485. So we got pi cubed. We got 485 minus. So that's going to be 5 times 5 is 25, 125. So that's minus 125. And what do we got on that for all my friends out there that can do math in their head at the speed of light? What was that? Phone went off, said something. Let's see, I end up getting 120. Oh, I hope that's it. You know, I work all this stuff out on the fly. I don't have this worked out on a piece of paper and I'm looking at it. Everything's getting worked out on the fly here. Well, looks like it goes along with the script. And of course, I check this with different kinds of algebraic systems, make sure everything's good. And yep, looks like that's it. Come on over to go2math.com. Things are starting to get tougher. Oh, you don't even know what's coming. All right, I'll talk to you later. Bye.